Good morning, dear students. So, after the completion of equilibrium, the physical portions actually completed. So, today here we are going to start a new chapter, that is redox reactions. So what is redox reactions? So redox reaction is actually a reaction where oxidation and reduction takes place simultaneously at a time. So in our everyday life, in our day-to-life, we come across various types of chemical reactions in natural processes, also in natural way. So what is the aging of uh, human beings or the falling of leaves, so falling of leaves from trees. So all these phenomena actually that are carried out due to some chemical changes. So during there are different types of reactions. Among them, the redox reaction is one. So redox reaction is one where oxidation and reduction takes place simultaneously at a time. So what is oxidation reaction and what is a reduction reaction? So there are different concepts to define this oxidation. Earlier you know that is the addition of oxygen or removal of hydrogen is known as oxidation, whereas addition of hydrogen and removal of oxygen is known as reduction. Or we can say not only the addition of oxygen but addition of any other electronegative element. Okay, that is also known as oxidation. So oxidation is a process where either addition of oxygen or removal of hydrogen takes place, or addition of electronegative element or removal of electropositive element takes place. So that is known, that reactions are known as oxidation reactions. Look here some example. Carbon plus oxygen give rise to carbon dioxide. Similarly, magnesium plus oxygen give rise to 2MgO. So here oxidation of carbon, oxidation of magnesium takes place because oxygen is added to them. Similarly, removal of some hydrogen, for example, H2S plus Cl2 is there. It gives rise to 2HCl plus sulfur. So from this hydrogen sulfide, this hydrogen is removed. And this addition of this chlorine also takes place with this sulfur. This Cl2 is added. So this electronegative element. So this process in H2S, but in H2S oxidation takes place. So from H2S to sulfur, this process is known as oxidation. This process is known as oxidation. So these are some reactions. PbS plus 4O3 give rise to PbSO4 plus 4O2. So here oxygen is added to this PbS lead sulfide in this Pb sulfide. So this is known as your oxidase. So this reaction PbH to PbSO4. So this is known as your oxidation. Magnesium to magnesium oxide, carbon to carbon dioxide. All these reactions are oxidation reactions. And the substance or the reagent which helps in oxidation, that are known as your oxidizing agents. So what are the different oxidizing agents? In this case, oxygen is the oxidizing agent. Here also oxygen is the oxidizing agent. Here chlorine is the oxidizing agent. Electronegative element, it helps in oxidation. So addition of electronegative element is also known as an oxidation. Okay. A removal of hydrogen is also known as so chlorine helps for the removal of hydrogen. In this way, we can undergo oxidation. And PbS plus 4O3 where ozone acts as an oxidizing agent. Okay, so which helps in oxidation is known as oxidizing agent. Next come to what is reduction. So reduction is a reaction where removal of oxygen or addition of hydrogen takes place. And we can say removal of electronegative element or addition of removal of electronegative element or addition of electropositive element takes place. That is known as reduction reaction. So reduction reaction, what are the reduction reaction? For example, N2 plus 3H2 give rise to 2NH3. So here addition of hydrogen takes place. So hydrogen is added. Similarly, CH2 double bond CH2 plus H2 in presence of nickel at nickel, it gives rise to CH3 ethane. Here what happens? Addition of hydrogen takes place. So addition of hydrogen. So this is your reduction process. Addition of hydrogen. Similarly, removal of oxygen ZnO plus C give rise to Zn plus C. Similarly, Fe2O3 plus 3CO give rise to 2Fe plus 3CO2. Here, removal of oxygen takes place. Here, removal of oxygen takes place. So, addition of hydrogen or removal of oxygen or addition of any electropositive element or removal of any electronegative element is also known as redox reaction. Is known as reduction reaction. And whenever oxidation takes place, and the substance which is helpful for the reduction that are known as the reducing agents. For example, where hydrogen is the reducing agent, here hydrogen is the reducing agent, here carbon is the reducing agent, here carbon monoxide is the reducing agents. So these are some examples of reduction reactions. And the reaction where both oxidation and reduction takes place simultaneously, that is known as the redox reaction. Look here, one example. Suppose one example is here, SnCl2 plus 2HgCl2 give rise to SnCl4 plus Hg2Cl2 is there. So this is one reaction. So what happens here? In SnCl2, number of chlorine atom 2, here number of chlorine atom there is 4. But when addition of chlorine, so here in SnCl2, it is converted to SnCl4. What happens here? Addition of chlorine takes place. Such addition of chlorine means addition of electronegative element. That means this process is oxidation. So this process is oxidation. In HgCl2, there are 4 chlorine atoms, but here 2 chlorine atoms. In this case, what? Removal of 2 chlorine atom takes place. So removal of 2 chlorine atom is electronegative atom. Removal of electronegative atom or removal of oxygen is known as reduction. So in this process is known as reduction process. So this is reduction process and this is oxidation process. And which helps in oxidation? So any substance which undergo oxidation itself acts as a reducing agent, and which undergo reduction acts as oxidizing agent, and which undergo oxidation acts as a reducing agent. Look here, HgCl2, here reduction takes place. In this HgCl2 acts as a reducing agent. This is your reducing agent. And SnCl2, this is undergo oxidation. So, which undergo reduction, that acts as your oxidizing agent. Which undergo reduction? This is the reduction process. HgCl2 undergo reduction, where removal of electronegative element takes place. This is reduction process. So it acts as an oxidizing agent, whereas SnCl2 give rise to SnCl4, oxidation takes place. So this acts as your reducing agent. So this is a reducing agent. In this way, which undergo oxidation acts as your reducing agent, which undergo reduction acts as your oxidizing agent. So this is the old concept or classical concept of oxidation reduction. In some cases, it also becomes very confusing. Whether it undergo oxidation is other it undergo reduction. But when we consider the oxidation and reduction in terms of electronic concept, new concept, it becomes more easier to know whether oxidation takes place or reduction takes place. And total this reaction where oxidation and reduction takes place at a time, this is known as a redox reaction. So this reaction is a redox reaction where oxidation takes place and reduction takes place. This reaction is known as a redox reaction. And another concept for this redox reaction is electronic concept. According to electronic concept, oxidation is a process where loss of electron, where electron is lost. Okay, so oxidation is loss of electron and reduction is gain of electron. Look here. So Na give rise to Na plus electron. Okay, similarly Ca give rise to Ca2 plus electron, and Cl minus give rise to Cl plus electron. S minus 2 give rise to S plus 2 electron. So when there is loss of electron takes place, that is known as oxidation. So these are the process of oxidation. Okay. Then what is the reduction? Reduction means where the gain of electron takes place. Gain of electron. Gain of electron, that is the reduction. Okay, sometimes the process, for example, Cl plus electron give rise to Cl minus, O plus 2 electron give rise to O2 minus, or we can say similarly Na plus electron give rise to Na, or S give rise to sulfur plus 2 electron give rise to S minus 2. So these are gain of electron. So these are known as reduction process. So these are reduction process where gain of electron takes place when the species gains electron, and these are oxidation process where the species loses electron. So look here, in oxidation either the positive charge increases or the negative charge decreases. So there is decrease in negative charge. Cl minus is converted to Cl and S minus 2 is converted to S. So minus 2 to 0. That is minus 1 to 0. So the negative charge value decreases and the positive charge value increases in case of oxidation. And in case of reduction, the negative charge value increases and the positive charge value decreases. Okay, so these are similarly Ca2 plus, if it receives 2 electron, give rise to Ca. So these processes are known as reduction processes, and these processes are known as oxidation processes. So any substance which undergo oxidation, that acts as your reducing agent. So here Na give rise to Na plus electron. In this Na, the alkali metal, they have more tendency to lose electron. That means they undergo oxidation. So they act as your oxidizer. They act as your reducing agents. So which have the tendency to undergo oxidation, that acts as your reducing agent. Okay, so the alkali metals and alkaline earth metals, these are used as reducing agents. So it has more tendency to lose electron, they undergo oxidation easily. In this way, these are acts as your reducing agents. Similarly, the halogens, they have more tendency to receive electron. The chalcogens, they have the tendency to receive electrons, to gain electrons. So as they gain electrons, that process is known as reduction. So any substance which undergo reduction, that acts as your oxidizing agent. In this way, as the halogens, they have more tendency to receive electron, they undergo reduction easily, hence these halogens act as your oxidizing agents. So actually reaction, any half reaction, actually when there is oxidation, that means if there some species is there to lose electron, and there should be some species to gain that electron. if some species is there to lose electron, there should be some species to gain that electrons. In this way, oxidation and reduction reaction takes place actually simultaneously. So only loss of electron, this is actually not possible, and only gain of electron, that is also actually not possible. Actually, this only half reaction, this is called oxidation half reaction and reduction half reaction. These half reactions are actually not possible. If there is some oxidation process, there should be some reduction. So in this way, oxidation and reduction takes place simultaneously, and that reaction is known as redox reaction. Okay, I think you clear what is the redox, what is about redox reaction. One thing here, suppose C plus O2 give rise to CO2. In the classical concept, when we consider that the carbon receive this electron, so carbon undergo oxidation. But what happens to the oxygen? To the oxygen, it undergo reduction. Okay, so it undergo reduction, it undergo oxidation. In this way, whenever there is oxidation, there should be one reduction reaction. So oxidation and reduction takes place simultaneously. Okay, so first note down these points. So look here, classical concept of oxidation and reduction. So according to classical concept, oxidation may be defined as a process. Let us first study about oxidation. So oxidation may be defined as a process which involves the addition of oxygen or addition of any electronegative element or removal of hydrogen or removal of any electropositive element. Some examples are, so here the example of addition of oxygen, here the example for addition of electronegative element, and here the example for removal of hydrogen, and here the example for removal of electropositive element. So these processes where it undergo oxidation. Here carbon undergo oxidation, magnesium undergo oxidation, FeCl2, ferrous chloride undergo oxidation, H2S undergo oxidation, and potassium iodide undergo oxidation. And substance which helps in oxidation or which brings about oxidation is known as oxidizing agent. So here oxygen, chlorine, bromine and hydrogen peroxide, these are you act as oxidizing agents. So note down these first. So look here, reduction. Reduction may be defined as a process which involves the addition of hydrogen or any electropositive element or removal of oxygen or any electronegative element. Removal of oxygen or removal of any electronegative element. Addition of hydrogen or addition of any electropositive element. Some examples are there, nitrogen, hydrogen, ammonia. Similarly, ethane plus hydrogen give rise to ethane. SnCl2, HgCl2 give rise to SnCl4 and Hg2Cl2. So here fluorine 1Hg and another Hg2 is added there. So 2Hg2Cl2 and ZnO plus carbon give rise to Zn plus CO. 2FeCl3 plus H2 give rise to FeCl2 plus 2HCl, the removal of electronegative element, fluorine. Okay, takes place. So these are some examples of reducing agents which helps in reduction, that is known as your reducing agents. So here hydrogen helps in reduction, here FgCl2, mercury chloride helps in reduction, here carbon helps in reduction, and here hydrogen helps in reduction. In this way, these are known as reducing agents or reductants. So according to electronic concept, oxidation may be defined as a process in which an atom or an ion loses one or more electrons. So as a result of oxidation, there is always increase in positive charge or decrease in negative charge. Increase in positive charge or decrease in negative charge. So the species which lost electron during oxidation is known as a reducing agent. So here sodium, calcium, ferrous, manganate, chloride and sulfide ions act as reducing agents. Next, Come to reduction. According to electronic concept, reduction may be defined as the process in which an atom or an ion gains one or more electrons. The gain of electron is also called electronation. The loss of electron, de-electronation, which is called electronation. So as a result, there is increase in negative charge or decrease in positive charge. There are some examples. So here the species chlorine, sulfur, stannic, ferric and sodium ion acts as your oxidizing. So they undergo, so all these they undergo reduction. So they act as oxidizing agent. So which receives electron that which gains electron that acts as your oxidizing agents. So in this species acts as your oxidizing agents. Remember, sodium atom acts as your reducing agent, while sodium ion acts as your oxidizing agent. Okay. So similarly, halide ions act as your reducing agents, but the halogens act as your oxidizing agents. Halogens oxidizing agents, but halide ions that acts as your reducing agents. I minus, Cl minus, these are your reducing agents. So note down this. So oxidation is loss of electron, while reduction is gain of electron. So if there is some species to lose electron, then there should be some another species that should gain electron. In this way, the oxidation or this reduction, the loss of electron do not take place independently, or the gain of electron do not take place independently. So that should, if there is a loss of electron, there should be one gain of electron. So in this way, a reaction which takes place by the transfer of electron from the reducing agent to the oxidizing agent, that is called the redox reaction. A chemical reaction which takes place by the transfer of electrons, the reaction is known as redox reaction. Look here, suppose we consider about the reaction of sodium plus chlorine give rise to sodium chloride. So in this case, the sodium has charge. Sodium loses electron Na. So 2Na give rise to 2Na plus 2 electron. So sodium loses electron, and chlorine Cl2 plus 2 electron give rise to 2Cl minus. And this combination of this gives rise to 2NaCl. So here electron transfers from the sodium to chlorine. So here it loses electron, it gains electron. In this reaction is a redox reaction. So this is a redox reaction. Similarly, suppose you consider another zinc plus, suppose 2 HCl is there, give rise to ZnCl2 plus H2. So what are the ions present here? Look here. So when we consider about this reaction, the dilute condition, it zinc plus 2H plus 2Cl minus give rise to Zn2 plus 2Cl minus plus H2. In this way, these ions are present. So here zinc converted to Zn2 plus, there is loss of electron, and H plus is converted to H2, that is gain of electron. In this reaction, this is loss of electron, in one case gain of electron. So this reaction is known as a redox reaction. So this redox reaction also takes place in two steps. One is known as oxidation half reaction, another is known as a reduction half reaction. So in these two steps this reaction takes place. For example, zinc give rise to Zn2 plus 2 electron, and 2H plus 2 electron give rise to H2. So in this way, this is also two-step reaction. This is also two-step reaction. One is oxidation half reaction, another known as reduction half reaction. This is oxidation half reaction, and this is reduction half reaction. and all total the reaction is a redox reaction. Similarly, here this is the oxidation half reaction and this is the reduction half reaction, and this all total is the redox reaction. So redox reaction is a reaction where a chemical reaction takes place by the transfer of electrons. Okay, so it is easier to find out whether the electron transfer takes place, how the ions are formed in case of ionic compounds. So the ionic compounds when undergo dissolution in water, then how this electron transfer takes place, it is easier to find out. But when we consider about the covalent compounds, then it is becomes very difficult to find out how the electrons lost, because covalent bond is formed by the sharing of electrons. So the covalent bond is formed by the sharing of electrons. In this way, how these electrons lost or how or where the electrons gained, to find out this, actually this becomes difficult. In this way, another term is used here, that is known as oxidation number or oxidation state. So the oxidation number or oxidation state, it is it's very helpful to find out whether the loss of electron or the gain of electron takes place. So in some cases, this oxidation number is similar to the valency of an element or the valency of an ion, but there is also still some difference between this oxidation number and valency. So what is the oxidation number? This oxidation number is generally assigned, is applicable in case of ionic compound as well as in case of covalent compound. So what is this oxidation number? So oxidation number, this is the number assigned to an atom, or the number assigned to an atom, or the residual charge of an atom or appear to have when all other atoms are removed as ions. If all other atoms are removed as ions, then what is the residual charge assigned to an atom? That is known as its oxidation number. So generally, if a compound is formed, a covalent compound is formed between atoms of different electronegativities, then the atom which is more electronegative, that is assigned the negative charge, and which is less electronegative, that is generally assigned the positive charge. For example, look at HCl. So between hydrogen and chlorine, so a covalent bond is formed between hydrogen and chlorine. Chlorine is more electronegative than hydrogen, and its valency is 1. In this way, in this case, what is chlorine? How it is present? The chlorine is taken as it has the oxidation number -1. So as it has the oxidation number -1, then hydrogen has the oxidation number +1. Okay. So in this way, the oxidation number of an element is determined. So there are some rules to find out the oxidation number of an element. For example, so there are some rules. So what are the rules? So first, the oxidation number of all elements in their free state, or in the stable state, is equal to 0. For example, the oxidation number of O2, the oxidation number of nitrogen in N2, hydrogen in H2. So in this case, the oxidation number of all elements in the most stable state, in the free state, is taken as 0. And the oxidation number of an element or atom, when it forms some compounds, or when it forms in ionic form, then the oxidation number of an atom in its ionic form is equal to the charge of the ion. Similarly, the oxidation number of electronegative elements are taken as negative, and the oxidation number of electropositive elements are taken as positive. Next, the oxidation number of alkali and alkaline earth metals are always taken as +1 and +2 respectively. The oxidation number of hydrogen when it combines with metals is taken as -1, and when it combines with non-metals is taken as +1. So oxidation number of hydrogen when it combines with sodium hydride, so it is taken as here -1, this is the +1, and the oxidation number of hydrogen when it combines with non-metal is generally taken as +1. So the oxidation number of fluorine, the more electronegative element, is always taken as -1. The oxidation number of oxygen in its compounds is generally -2, but oxygen from there are different types of oxides. In oxides, this is -2. If this is peroxide, this is -1. But oxygen, when combines with fluorine, it has oxidation number +2 and +1 when combines with the fluorine. That means OF2 and O2F2. Okay. In this case only positive, all other case, because oxygen is highest electronegative element next to fluorine. Next to fluorine is always negative. The oxidation number of halogens is generally taken as -1, but when they combine with, they are taken as -1. Then the oxidation number of all elements in a molecule, in a neutral molecule, is equal to the sum of oxidation number of all elements in a neutral molecule is equal to 0, and the sum of oxidation number of all atoms in an ion is equal to the charge of the ion. For example, sulfate ion is there. So sulfate has SO4 -2. In this, the sum of oxidation number of sulfur and oxygen here, that is equal to -2. Sum of oxidation number of sulfur and oxygen, that is equal to -2. And the oxidation number of, suppose on the potassium permanganate, KMnO4, then the oxidation number of all atoms, that is equal to 0. So if it is a neutral molecule, oxidation number is 0. If it is an ion, then sum of oxidation number of all atoms is equal to the charge of the ion. And for the oxidation number of some ions are given, Na plus, it has +1. Okay, Cl minus, it has -1. S -2, it has -2. In this way, oxidation number of an ion is equal to the charge of the ion. Oxidation number of free elements is equal to 0. Fluorine is always -1. Oxygen has -2 in oxides and -1 in peroxide. But when combined with fluorine, it has positive oxidation number. Then alkali, alkaline earth metals has always +1 and +2 oxidation number respectively. And the sum of oxidation number is equal to 0. So considering all these things in mind, we can assign, we can find out what is the oxidation number of any element in a compound or in an ion. Okay. So now first look out what are the rules. Then let us find out what is the oxidation number of different species. So first note down these points. What is the oxidation number? The oxidation number is the residual charge of an atom has or appear to have when all other atoms are removed as ions. So there are rules to calculate the oxidation number. That means what is the actual charge present, or what is the charge, if all atoms are removed, what is the charge assigned to that atom? That is known as the oxidation number. So the oxidation number of an element in all elemental form is 0, whether in atomic form or in molecular form of all elements is equal to 0. In a single monoatomic ion, the oxidation number of the atom is the charge on the ion. For example, in Ca2 plus, calcium has oxidation number +2. In Cl minus, chlorine has oxidation number -1. In sulfide, sulfur has oxidation number -2, like this. So if a compound is formed by the combination of two nonmetals, suppose from chlorine oxygen or nitrogen chlorine or chlorine fluorine, if it is formed between two nonmetals, then the element which is more electronegative, that is given the negative oxidation number, and which has given which is less electronegative, that is given the positive oxidation number. Similarly, when a compound is formed between metal and non-metal, the oxidation number of metal is always positive and that of non-metal is always negative. So first note down these 4 points. So look at here. The oxidation number of hydrogen is +1 when it combines with nonmetals and -1 when it combines with metals. Similarly, the oxidation number of fluorine in all its compound is -1 as it is the most electronegative element. The oxidation number of oxygen in its compound is generally -2. So when it forms oxides, but in peroxides, this is -1. In superoxide, this is -half. So but when it combines with fluorine, it compounds two compounds, that is O2F2 and OF2. In OF2, the oxidation number of oxygen is +2, and in O2F2, the oxidation number of oxygen is +1. The oxidation number of alkali and alkaline earth metals are always +1 and +2 in their compounds. But remember, in free state, this is 0. But in component form compounds, it has +1 and +2. Similarly, in the neutral molecule, the oxidation number of all atoms is equal to 0. Similarly, in a complex or a polyatomic ion, the oxidation number of all atoms is the sum of oxidation number of all atoms is equal to the charge of the ion. Okay, so note down this. Let us solve how to find out the oxidation number of some atoms or some species. Okay, so given, find out the oxidation number of nitrogen HNO3, manganese in KMnO4, chromium in K2Cr27, phosphorus in H3PO4. So to find out this, first you have to keep in mind what are the rules. You have to go through the rules and you have to keep in mind what are the rules, then try to solve. You have to find out the oxidation number. For example, HNO3. So if you don't know what is the oxidation number of N element, let it the oxidation number of the element be X. So let it be X, then you can solve. Okay. So let the oxidation number of nitrogen is X. So the oxidation number of nitrogen is X, and we know the sum of oxidation number of all elements is equal to 0. So hydrogen here combines with nonmetals. In this it has oxidation number +1. So now for hydrogen +1, for nitrogen X plus 3 oxygen and 1 oxygen has oxidation number -2 and 3 oxygen has oxidation number 3 into -2, that is equal to 0. The sum of oxidation number of all total elements or all total atoms is equal to 0. So hydrogen +1 and nitrogen X and oxygen has 3 oxygen, 1 oxygen has -2, 3 oxygen, 3 into -2, that is equal to 0. So in this way, X plus 1 and 3 into -2, that is equal to -6 equal to 0, or X is equal to +5. So the oxidation number of nitrogen here is +5. Next come to 2. Manganese in KMnO4. Let the oxidation number of manganese. Let the oxidation number of manganese is X. Then the sum of this number of all atoms in the molecule is equal to 0. So then, and potassium is the alkali metal. As it is the alkali metal, its oxidation number is +1. Then, so +1 plus manganese has X plus 4 into -2, that is equal to 0, or X plus 1 minus 8 equal to 0, or X minus 7 equal to 0, or X equal to +7. So the oxidation number of manganese in potassium permanganate is +7. Next, what is the oxidation number of chromium in K2Cr2O7? So chromium given, let the oxidation number of chromium is equal to X. Then 2 chromiums are there. So then 2 into plus 1. So this plus 1 is for potassium. Potassium is the alkali metal. For this plus 1, 2 into plus 1 plus chromium. 1 chromium has X, 2 chromium, 2X plus oxygen. 7 into 1 oxygen has minus 2. So 2 plus 1, 2H plus 7 into minus 2, that is equal to 0, or 2, or that is equal to plus 2 plus 2x minus 14 equal to 0, or 2x minus 12 equal to 0, or 2x is equal to plus 12 and x is equal to 12 by 2, that is plus 6. So in this oxidation number of chromium here is plus 6. Okay. Next, what is the oxidation number of phosphorus in H3PO4? So in H3PO4 it's given. So if you don't know what is the oxidation number of phosphorus, let it be X. Let the oxidation number of phosphorus is X. As the oxidation number of phosphorus is X, then all total sums hydrogen, it is also attached with electronegative part, this is attached non-metals, combines non-metals. Hydrogen has oxidation number, hydrogen has oxidation number, that is plus 1. So there are 3 hydrogen atoms. So then 3 plus 1 plus X plus 2 plus 4 into 1 oxygen minus 2, all total that is equal to 0 in this way, or plus 3 plus X plus minus 8 equal to 0, or X minus 5 is equal to 0, or X is equal to 5. In this, the oxidation number of phosphorus in H3PO4 is 5. Okay, you can solve in this way. Next, find the oxidation number of underlying elements in the following. Okay, so first, let it be X, manganese X, plus sum of oxidation number of all atoms in the ion is equal to the charge of the ion. In this X, plus there are 4 oxygen atoms, so 4 into minus 2, it is equal to minus 2, because what is the charge on this, the sum of oxidation number of all atoms is equal to charge. What is the net charge? That is minus 2. So X plus 4 minus 2 is equal to minus 2, or X minus 8 is equal to minus 2, or X is equal to plus 6. So in this way, here in MnO4 2 minus, the oxidation number of manganese is plus 6. Next come to number 2, Ag2Cr4. So silver as its oxidation number is plus 1. It is similar to the alkali metals. In this its oxidation number is plus 1, and there are 2. Let the oxidation number of chromium is X. So in this way, 2 into plus 1 plus 2x plus 4 into minus 2, that is equal to 0. So 2x plus 2x first come here, and plus 2, 4 into minus 2, minus 8 is equal to 0, or 2x, 2 minus 8 minus 6 is equal to 0. So, okay, so 2x minus 6 equal to 0, or 2x is equal to plus 6, x is equal to plus 6 by 2 plus 3. So in silver chromate, the oxidation number of chromium here is found to be plus 3. Next come to here, FeCN63 minus. So in this case, there is FeCN63 minus. The sum of oxidation number of all ions is equal to the charge of the ion, and here cyanide is present. The cyanide has charge -1. So oxidation number of Cl minus, that is equal to -1. In this way, let the oxidation number of iron is X. So this implies that X plus 6 into -1 is equal to -3. So in this way, X minus 6 equal to -3, or X is equal to +3. So here the oxidation number of iron is +3, that is in ferric form. Next come to here CrH2O whole 6 3 plus. So here chromium, water is a neutral molecule. As water is a neutral molecule, so the oxidation number of H2O is equal to 0, because this is a neutral molecule. So in this way, let the oxidation number of chromium is X. So in this way, this implies that X plus 6 into 0, that is equal to +3, or X plus 0 is equal to +3, or X is equal to +3. So in this complex, chromium has oxidation number +3. In this complex, iron has oxidation number +3. In this complex, the oxidation number of chromium is +3, and in this iron, the oxidation number of manganese is +6. Suppose given what is the oxidation number of iron in FeSO4. So it consists of two parts, that is Fe2 plus and SO4 2 minus. So total sulfate has 2 minus. In this way, if suppose the sulfate, as the sulfate is there, so the sulfate has oxidation number -2. So you can write X plus -2 is equal to 0, or X is equal to +2. So in FeSO4, iron has oxidation number is +2. So in this, if this ion given, you can find out the oxidation number. So now some homework for you to find out the oxidation number of these. So oxidation number of sulfur, and the oxidation of sulfur in these following compounds, and the oxidation number of carbon in these followings, and the oxidation number of manganese in these followings, and the oxidation number of nitrogen in the followings. Just here I want to say one thing, that is I have done one mistake to find out what the oxidation number of chromium when it is given Ag2CrO4. In Ag2CrO4, look here, in Cr there is no 2, but I have assigned that there is 2 chromium atom. In this I have done one mistake there. So just you can solve this. Let us solve again. So suppose the oxidation number of chromium is here, that is X. Then silver is a transition element, is similar to the alkyl metal. In this case, oxidation number of silver is +1. Here silver has +1. So in this way, 2 into +1 plus X plus 4 into -2, it is equal to 0. So 2 into +1, it is equal to, this implies that +2 plus X, 4 into -2, plus 2 plus X plus 2 plus X minus 8 is equal to 0. This implies that X is equal to +6. So in silver chromate, this chromium has oxidation number +6. But by mistake I have written that there is 2 chromium there. So it is found in +3, but that is wrong. The chromium has oxidation number +6. Okay.